Professor, a lot of thanks for accepting our interview. As a well-established scholar, we know you published a pioneer paper in 2020, which title is What 6G Should Be, where you focus on that intelligence will be a prominent future for 6G, including operational intelligence, environmental intelligence, and service intelligence. Given the rapid progress of AI technology during the past years, and especially the large AI model, so what the new ideas and the viewpoints you would have if you rewrite the paper today?
Yes. Yeah, thank you for this very valuable question. Indeed, when we wrote that paper in 2019, it was the early days of kind of 6G brainstorming. AI started kind of becoming important. We all realized at that time that AI will have an important role to play in the evolution of future generation of wireless network. But to be honest, I didn't predict at that time, or I was not kind of feeling that it will have this major impact. I think the impact is even bigger than what I thought at that time. So if I had to rewrite that paper with my colleagues, probably would have or let's say we would have further emphasized the importance of AI. As we see now, and I have to be honest, this is not my main area of expertise. I do a little bit of work of AI for communication. Like all of us, we need now to understand AI as a tool to design and to basically optimize the performance of wireless network. But this is not my kind of main focus area. Nonetheless, reading papers, talking to experts and colleagues in the community, I feel that the potential of AI to optimize radio resource allocation, to help with the maintenance and predictive maintenance of network, to help with predicting cyber attacks, to help with optimizing the energy efficient network is really tremendous. That's the least we can say. We are truly going into this era of self-operating network, and the AI will have a big role. Of course, if we do things right, if we keep improving AI techniques and AI tools to help the basically optimization, operation and maintenance of future generation of wireless networks.
Okay. It appears that you always do some pioneer work. We own the optical technology and the wireless technology are two relatively independent fields, but you have done a lot of work for convergence of these two different technologies. So what's the motivation and what's the progress? And also we want to know what's the benefit of convergence of these two different technologies, and we also want to know what's the application scenarios of these convergence technologies.
Yeah, thank you. Yeah, actually, I am by training and my original work focused on RF wireless communication. That was the work done during my PhD and my early years as a faculty member. But then a little bit more than 10 years ago, I realized that actually many of the mathematical methods and performance analysis techniques we use to analyze RF communication systems can also be extended, generalized, let's say, to optical wireless communication, which was an emerging field in the early 2010 era. So since then, I have indeed been quite active in the area of optical wireless communication, and like you said, in a very correct fashion, I see these two technologies as complementing each other, not as competing with each other. They complement each other because we all know that RF spectrum is getting more and more limited. We, of course, need to keep using RF technology, but we need to explore other part of the spectrum, another part of the spectrum where there is abundant kind of available frequencies and wavelength, and naturally the optical band is there, and we can capitalize on that to work with RF band to bring the capacity we need to basically deploy this very hungry in terms of capacity network. So I indeed see optical wireless communication as a complement to RF communications, and with a particular basically application, for example, for backhaul and feeder link. So for instance, when we talk of free space optics, that's a technology that is quite mature. Of course, it has some sensitivity to weather conditions, but in many parts of the world is still quite robust. And when you, let's say, combine it with a good RF backup link, you can have a very reliable backhaul solution to reach remote areas, islands, to enable the future of connectivity that a big part is going to come from non-terrestrial network. So I think there is a big future for this kind of convergence between optical and RF wireless communications.
So do you think it will be a widely used technology, the convergence of optical and wireless technology?
I think so, that there will be some good complementarity in certain scenarios. Again, for instance, when you talk about the backhaul, let's assume you want to connect a remote island that is 15, 20 kilometers away from the shore. You have good connectivity of the shore. You are not able to connect the island. It costs a lot of money to put submarine cable. Satellite capacity is not enough. You know, putting a fiber over the air solution, a fiber over the air, meaning by that free space optic, a laser that is going to transmit over the air, is a great solution. The fact that it is not always available because maybe of fog, because maybe of wind, can be made, we can make this link more reliable by putting a backup RF link that can provide the extreme reliability that we are after. So, you know, there are scenarios where indeed, clearly I can see a good usage of these convergence between optical and RF technologies.
Okay, and so I'm curious, what's the main challenge to take the different technology convergence?
I think one of the main challenges is that optical wireless communication technology faced is this kind of, in a way, some of it is true, some of it is a perception of unreliability, of the fact that it's very sensitive to weather condition, that it requires a lot of maintenance, meaning by that, you know, every time there is a little storm or wind, things get misaligned, so you don't have any more this nice pointing that is required for an optical communication system to work perfectly. You need to send a crew and try to realign and re-establish the link. That was true for the early generation of product, but I think now there has been quite a bit of effort from the academic side, but also an industrial side, to develop more mature free space optic transceivers that can realign, that can re-establish connection on their own, and that make them more reliable, easier to maintain, and I think more acceptable by the operators, in my view, down the road. And the other challenge is in the context of using optical wireless communication, in particular free space optic, for the emergent, in my view, huge market of non-terrestrial network, connection with drones, connection with high altitude platform station, connection with satellites. You have to deal also with weather condition, clouds that can block, for example, the transmission of the links. But there are solutions. You know, you can, obviously, what you need is not a point-to-point type of deployment. What you need is a network on the ground of optical gateway station that will provide site diversity. So the probability that all the link will be blocked at any given time is very small. Because if you place your optical gateway station in a location that are basically well chosen ahead of time, so that the probability of all of them being blocked by clouds based on historical data, etc., doesn't happen, makes that the network will be always available. So there are challenges, you know, maintenance, clouds, pointing mechanisms. Also, sometimes if you are looking at low-cost deployment, affordability. How can we lower the cost of these transceivers to make them more affordable and in a way more ready to be massively deployed for terrestrial application?
Yeah, in this morning's keynote, you showed a chart with the title, "The Wide Connectivity Divide." So, you know, we know you in recent years, you have been advocating the concept of connect the unconnected, and you mentioned the scenario and the use of convergence of optical and wireless technology. Maybe that part of connect the unconnected. When we mentioned about connect the unconnected, I think you may have paid some attention on Starlink.
Yeah, so definitely this is one of my main research area and my main research interest these days. This is not new. I have been active in this area since 2017 or 18 because we live in a world where we still have 1/3 of world population unconnected and underconnected. We are talking nearly 3 billion people who are not fully taking advantage of the benefit that come with internet. To me, that's also an important problem that we have to solve beyond the kind of pushing the envelope target that every single generation naturally is trying to go after, trying to go to higher speed, more capacity, lower latency, more massively developed IoT device. That's good that we need to do that, but I think there is another important problem. We need to democratize. We have to give more access to internet because internet can bring a lot of benefits and can bring prosperity to many of these rural, low-income, remote regions of the world. And that's why I feel strongly about solving or contributing to solving connecting the unconnected type of problem with which in a way showed us why what showed us this problem is important also is, like, for example, during COVID-19. We have seen during COVID-19 worldwide that the connectivity divide is one manifestation or one face of inequality between the people who have and who do not have connectivity, people who can continue working thanks to connectivity, and those who have to give up education and work because they are not connected. So to me, that's really the main motivation that, or strengthen my motivation to work on these kind of problems. And to further, I would say, put another final argument behind why it's important to look at connecting the unconnected problems, because we tend to forget, those of us who live in very well connected environment, that this connectivity is actually volatile. We can lose it any time because of a natural disaster or man-made catastrophe, like an earthquake, a flood, a volcano eruption. Your network on the ground is completely destroyed, and you have a kind of a unconnected problem overnight that you need to solve. So when you invest in research in this kind of in technology that can address this problem, in a way you are solving a variety of other important problems to humanity. So yes, this is a little bit the motivation behind why I am into this problem. And indeed, one way to bring connectivity to this remote region is from the sky and from the space. So Starlink is one example among I would say few others, and it's a perfect example showing how Starlink changed also in many ways the way we look at connectivity and global connectivity. But of course Starlink is not the only solution. It gave appetite, as you know now, it's a global race, we can say, towards sending more and more satellites. We have OneWeb, the British constellation, we have Lightspeed, Canadian constellation, we have G60, the Chinese constellation, Kuiper, the Amazon, US-based constellation. So all of these constellations will be part of our ecosystem in a few years, and we'll have this umbrella that will allow to bring connectivity to many parts of the world. Having said that, I don't think that's the ultimate solution. In my mind, we are living in a world where population density is not uniform. We have area where we have very high dense populations, we have area where we have medium density population, and we have area naturally with very low to pretty much no one living there. I don't think there is one size fits all to solve this problem. When you are in downtown, very dense urban environment, there is no need for satellite. You put your base station on the top of even maybe a lamppost or with Wi-Fi, and that's good enough to absorb that capacity. Obviously, as you go to more rural environment, you need to go higher altitude, satellite being the ultimate solution. But in between, where you are in suburban environment, you are in environment with medium type of dense population, I also believe in the near space or the stratosphere as a good layer to provide connectivity. So we are talking about the so-called high altitude platform station, known also as high altitude pseudo-satellite, in short HAPS. These are platforms operating roughly at 20 kilometer altitude above the troposphere in the stratosphere, and that can act as essentially tower in the sky to provide connectivity to this variable range of dense population that basically need also connectivity. So Starlink and satellite is part of the solution. I don't think it's the only solution. It should be part of a full ecosystem of different layers of non-terrestrial network that will accommodate and that will serve different level of dense population on the ground.
Professor, you published your famous book 20 years ago, Digital Communication over Fading Channels, and in this book you proposed several important performance metrics and developed a new analytic method for performance evaluation of communication system. And till now, almost 20 years have passed, and the communication system have changed greatly. So could you please introduce your recent research on this area?
Thank you for reminding me about this beautiful project that I did with the late Dr. Mohamed-Slim, a mentor and a person I enjoyed to collaborate with for many years, just after my PhD and my early career. So we wrote this book. Indeed, you know, it has been 20 years that this book was published in its second edition. At that time, that book I think was indeed a good summary of what I did during my PhD, as well as what the community of people working on what we call performance analysis over fading channel were doing. So it was an up-to-date manuscript on techniques involving moment rating based approach, order statistics. The idea was, how can we write a book that kind of focus on this area of telecommunication where you combine modeling and performance analysis? An area where you need to find the right model that is complicated enough to capture the reality, the complicated physical phenomena that we are trying to analyze, but also simple enough to be tractable mathematically. That was the main concept of the book. And what are the analytical tools that we can use from probability, statistics, random process to analyze these systems? So that book, of course, was up to date 20 years ago. In between, a lot of things have happened. First of all, we have many more performance metrics. At the time we wrote the book, we were focusing more on ouch probability, focusing more on average probability of errors. Now, we in a world where latency is important, age of information is important, there are other metrics that describe these kind of important, I would say, KPIs for a communication system at the physical layer that need to be analyzed. We looked also at energy efficiency as another important metric that we need to analyze, and that, of course, at that time was not as important as today. So I would say the performance metric have changed or have evolved, although we are still doing probability of errors and we are still doing ouch probability capacity type of calculation. And I think more importantly, the tools have dramatically improved. At my time, you need to have very good background in probability, statistics, order statistics, and these were the tools we used to analyze the kind of system we had at that time. With the evolution of the complexity of wireless networks, in between, over the last 20 years, we have seen stochastic geometry playing a big role, extreme value theory playing also a big role, random matrix theory when you talk about massive MIMO systems. All of these sophisticated mathematical tools are part now of the skill tool that someone in performance has to more or less master to be able to analyze current and emerging communication system. And of course, we cannot forget AI. We cannot forget that nowadays we just cannot ignore machine learning, data-driven performance evaluation and prediction. That is going to become also an essential tool and skill that we need to have as telecom engineer focusing on performance analysis. So yes, we need probably another edition of the book. Probably I will not write it. Maybe some of my students will write the next edition. But it's a good book. I think is still being used as a reference, but of course, a lot of development happened over the last 20 years.
Okay, it's all my questions.
Thank you.
Thanks.
Thank you very much.
Thank you very much.
Thank you.
For your time.
Thank you. Good.